want that you understand that if you select improper materials, improper alloys, or if you combine the similar metals, you can create or you can accelerate phenomena like corrosion. The atomic number refers to the amount of electrons in the orbits. Those electrons should be equal to the protons in the nucleus. In other words, each atom is neutral because the charge of the electrons is negative and the charge of the protons is positive. If I have the same amount of protons and the same amount of electrons, is because the charge of the atom is neutral. According with the amount of electrons in the last orbit, if you remember, the elements are organized in the periodic tables. Each element is composed by protons and neutrons in the nucleus, and in the orbits the elements have electrons. This is the octet rule. All the elements try to keep in the last orbit A electrons or 0. This is the octet rule. Once again, we are going to return. Group number 1, 1 electron in the last orbit. Group number 2, all of those elements have 2 electrons in the last orbit. Exactly the same with the group number 3, 3 electrons in the last orbit. 4, 5, 6, 7, and 8. What happened with this group? Located in this section. Those are transition metals. We are going to create molecules and compounds. For example, we are going to create a molecule that is stable. You remember the molecule of salt when you use salt in your home to prepare food? What is you remember the formula for salt? Is sodium and chlorine. Oh, how many electrons have sodium in the last orbit? Sodium is located in the group number 1, only 1 electron in the last orbit. What about chlorine? How many electrons have chlorine in the last orbit? 7 electrons in the last orbit. 7 electrons in the last orbit. What element have more electronegativity, more energy? What element have more electronegativity? According with the table that we have here, more energy. In that table, the electronegativities is energy, is voltage. Look at this, fluorine have 4 millivolts. This is the energy. Fluorine is the element in the periodic table with maximum electronegativity. What about oxygen? Oxygen have 3.5. It's high energy. What is the element with lower electronegativity in the periodic table? It's francium with 0.7 millivolts. In other words, the element located in this corner, they have the low level of electronegativity, and the elements located here, they have the higher level of electronegativity. Yes, water. Water is a perfect molecule. Water is basically oxygen with 2 hydrogens. Oxygen, how many electrons have oxygen in the last orbit? 6. And how many electrons have hydrogen in the last orbit? Only 1. Okay, what element have more electronegativity? Oxygen. What element attract? Oxygen. What element have low electronegativity, low energy? Hydrogen. Okay, hydrogen release the electron, oxygen complete 8, and hydrogen 0 and 0. And the molecule is stable. Perfect. This is another great example of a perfect molecule. My friends, in the periodic table, we are going to create a division. We are going to create a section. We are going to mark that section. You see here, 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 and here. In the bottom of boron, in the bottom of silica, in the bottom of arsenic, in the bottom of tellurium, in the bottom of arsenic. And we create that division. The elements located below the divisions are considered metals, and the elements located over the division are considered non-metals. What happened when the oxygen attacks zinc? Oxygen and zinc. All right, I have oxygen here with 6 electrons in the last orbit. And I have zinc, and zinc only have 2 electrons in the last orbit. What element have more energy? Oxygen, because oxygen is located over there in that corner of the periodic table. And what about zinc? Zinc have less energy because it's located below of the division in the periodic table. Okay, zinc release those electrons, oxygen complete A, and zinc 0. And this is a perfect molecule. This is oxide of zinc. Yes, copper, iron, aluminum, and you protect with a piece of zinc. Zinc is the sacrificial anode used to protect the rest of the metals.